I used Unity to create my very own version of Minecraft. Somehow I found that the base game, by nature, was still missing something. Something that kind of enlightens you with its presence. That somehow emits an infinite amount of power. Something like, oh, I got it. Lightsabers. Unfortunately, before I was able to add them to my base game, I somehow had to come up with the base game itself. So I started by adding a third-person player, textured cubes called blocks that the player is able to place and to destroy, and as you all guessed it, crafting, and then some miscellaneous stuff as well, obviously, like inventory, world generation, or enemies. And then I was finally ready to include lightsabers, that you can craft yourself by putting one iron block at the very bottom and then 2 redstone dust on top of it. But since that wasn't enough for me, and I also wanted to kind of stick to Minecraft's general formula, I added a golden lightsaber using a block of gold as well, and here you got your diamond version of it, with all of them dealing the attack of their sword counterparts +1. And now you might ask yourself, what, 8 ingots more? Just for +1 attack? And well, that's far from everything you'll get, as there are a few features to it that I haven't told you by now, like stacking knockback, epic blocking, color changing, dashing, and yes, that's right, even reflecting. Oh, and also please subscribe if you haven't already. My next Minecraft modification is gonna be just as awesome. And the way I added my lightsabers in the first place was by adding 3 more items to the game, which in Unity you can use scriptable objects for, which are a neat way to bundle data and behavior together. And then I needed to change some values, like the name of the item, the crafting recipe, and I also added a new item type called lightsaber. And of course I also needed to tell my workbench that these items exist now. And now that we got our first lightsaber, let's take a look at how Staggable knockback works. And this one I actually created by accident. And that was because I was using Unity's physics system. So as soon as the player clicks left, the camera emits a ray. Rays are invisible physical objects. And as soon as this ray hits something, we need to check whether it's an enemy. We don't want to use our lightsaber to cut blocks in health. And we also need to make sure that the enemy is within range, as we don't want to kill anything that's like 2 chunks apart from us. And yeah, then we decrease the enemy's health and apply a physical impulse to it that goes in the direction of the camera, plus some momentum to the upside, so that the enemy gets knocked back and also a bit up. And how you might see the problem, we don't check whether such an impulse has already been put on the enemy. And thus the force gets higher and higher the more often you click, eventually pushing the enemy right to the other end of the map. But now what about blocking? Well, this was fairly easy, as I just had to check whether the player is holding down the right mouse button. Then I could set a blocking flag to true, and I could also utilize Unity's animator state machine to create an idle state, where the player is holding his hand and thus the item just upwards like normal, and then making a second state for blocking, where the player is holding the item just in front of him, and then setting our previously created blocking flag as a condition to transition between these 2 states. And voila, there you got your blocking. But what would lightsabers be without changeable colors, so that you can play as your favorite hero or villain? And I want the player to be capable of changing the color by holding shift and clicking right. So I needed to check for exactly that in the code. And this time it wasn't really a problem that the player is still blocking while changing the color, because, well, you're still holding down the right mouse button. Whereas with dashing this will be a bit more of a problem, as you will see in a minute. So now we know that the player wants to change the color from the input, so we still need to do exactly that. For making the blade of the lightsaber, I was using this package that provides me with a specialized line renderer that I could simply access when switching the colors, and then loop through this list of colors that I created, and then to change the color attribute of the line renderer's material, which will cause the lightsaber's blade to reload. However, what would be a Star Wars-like game without... And with that I mean... So I thought it would be awesome to have dashing on shift and left click, but then the player was still performing this default attack on top of the dash, and that's why I needed to make the dash override the basic attack, so that the player is only able to perform one of these. And yeah, then the dash also consists of an animation with a transition, just like the blocking, and of course that gets applied to the player in the forward direction and a bit to the upside as well. And I have to admit that the first time I was testing this, my dash wasn't working at all, and that was because my normal movement system was kind of interfering into the dash, as the normal movement system constantly sets the player's velocity to whatever input the user makes. So if you want to perform a dash while not moving, your velocity will remain 0. But as you can imagine, Deactivating the normal movement system while dashing already does the trick here. Then we got reflecting, and honestly I just added skeletons and their arrows, just for the sake of reflecting here. So usually, when the arrow intersects with a collider, we want to destroy the arrow and maybe apply some damage to the object's hit. But in our specific case, we want to check whether the object hit is the player prior to it, and if so, rotate the arrow in the direction of the camera, and also its force that causes the movement. But not in any case, you know. We don't want the player to just reflect anything and become invisible. Instead, we need to check whether the player's blocking flag is actually set to true before reflecting the arrow. So the last thing I wanted to tell you is, if you're interested in how I created the base game in the first place, please check out this playlist, and have a nice day.